Hello, sixth graders. Today we are working on a fun little inquiry lab, multiply by powers of 10. I believe it is page 209. Yep, 209. Okay, let's look at this inquiry up here. It says, how can number patterns be used to multiply by powers of 10? Okay, what are powers of 10 anyway? Has something to do with when a number is just ones and zeros. Okay, let's read this problem. Each planet in our solar system orbits around the sun at a different distance from the sun. So what is an orbit? Okay, so let's see here, orbit. So if this is the sun, okay, and this is the earth, here's earth. What is the distance on that path? What is that path? What is the distance of earth to go all the way around the sun? Okay, and in this example, we're talking about Mercury. So what is the distance that it takes Mercury to go all the way around the sun? That's its orbit, okay? So let's finish reading this. It says Mercury orbits at an average distance of 28.6 million miles. 1 million is written like this, 1 with 6 zeros. So what is 28.6 times 1 million? In other words, what do we need to know? We're trying to figure out what 28.6 million is in standard form. What would it look like as a number instead of part number, part words? Okay, that's what we need to know. What do we already know? We know that Mercury's orbit, or the distance around the sun, Mercury's orbit, or its distance, equals 28.6 million. Okay, that's what we know. But we're trying to understand 28.6 million in standard form. Before we do that, we need to understand this idea of powers of 10. So numbers like 10, 100, and 1,000 are called powers of 10 because they can be obtained by raising 10 to a power. Okay, so we have explored that a little bit, like 10 squared, that's 10 to the power of 2, and we know that means 2 zeros, right? So 10 squared, or 10 times 10, equals 100. So we have explored this idea of powers of 10. We're just going to think of it in a new way. Okay, so I'm going to zoom in on this chart, all right? And let's see what we notice. All right, so 28.6, the decimal is between the 8 and the 6. When we multiply it by 1/10, 0.1, the decimal moves from between the 8 and the 6 to between the 2 and the 8. Notice it's the same numbers, 286, 286, okay? So like 5 times 1 is still 5, right? 28.6 times 1 is still 286, but that decimal changed the decimal placement. This is one digit to the right of a decimal. So something about the decimal in the product needed to move one place, all right? Specifically, it moved one place to the left. Got it? Let's take a look at the next one. This is 28.6 times 1. It's still 28.6. That decimal didn't move. Why? That is called the identity property of multiplication. Meaning if you multiply by 1, you're not changing anything. Okay? Let's look at the next one. 28.6 times 10. The decimal was between the 8 and the 6. Now the decimal is at the end because that's where you put a decimal on a whole number. So the decimal moved one place to the right. One place to the right. What do we notice? 1 0, right? Okay, we've done that before. If we're multiplying 5 times 10, that's 5 times 1 is 5, and there's 1 0. If we multiply 5 times 100, that's 5 times 1 is 5, and 2 zeros, 1, 2, right? We know this. We're just exploring it with a decimal now. All right, we have 28.6 times 1,000. Could we make a prediction? There are 3 zeros, so let's just try it. 1, 2, 3. Okay, so we moved 3 places. So it was between the 8 and the 6. 1, 2, 3. Yep, that's it right there. 3 zeros, move the decimal 3 places to the right. Okay, so we move the decimal place, the decimal point, the same number of places as the number of zeros in the power of 10. Okay, we move the decimal point to the what when multiplying by a power of 10 that is less than 1. So here's our example of less than 1. Remember, 0.1 is less than a whole, and we moved the decimal, in this case, 1 place to the left. Okay, to the left if our power of 10 is less than 1. We move the decimal place to the right when multiplying by a power of 10 that is greater than 1. So our examples up here, greater than 1, greater than 1. This one here is exactly 1, okay? So we went to the right if it was greater than 1, and to the left if it was less than 1. All right, let's finish this out. Determine how many zeros are in 1 million. 1, 2, 3, 4, 5, 6. There are 6 zeros in 1 million. And 1 million is greater than 1, right? So we're moving to the right. So we take 28.6 and we're going to go 6 places to the right. 1, 2, 3, 4, 5, 6. 6 places to the right, which creates the number 28,600,000. Not too bad, right? Just make sure you keep track of all that movement. Okay, so here you're going to explore patterns. So 12.4, this is 124, this is 124. Okay, so it was 0.1, that is less than 1, so they moved the decimal to the left, and it became 1.24. Now here, this is still less than 1. There are 2 digits after the decimal. So 1, 2. So that becomes 0.124. So follow the pattern on that. Let's look at one where the number is greater than 1. Or, well, actually the first one is not greater than 1. It's exactly 1. Okay, so let me fix that. This one is equal to 1. The rest of them will be greater than 1 in the second chart. So equal to 1, change nothing. That is the identity property. You can't change me. Okay, this one is 10. As 1, 0, move 1 place to the right. So that becomes 12.4 or 12 and 4 tenths. All right, so let's look down here at the create. It says, write a rule you can use to find the product of a number and a power of 10 without using paper and pencil or a calculator. So look here. Count the zeros to determine how many places to move the decimal. If it's division, move left. It's a multiplication, move right, except in the case when the power of 10 is less than 1, then you move left. Okay? All right. And in this one, how can number patterns be used to multiply by powers of 10? I thought in this one, an example might be better than a rule. Okay, so maybe 43.7 times 1 million is intimidating. It may not be familiar to us yet, but if we just think of a smaller number, that can help us remember what the pattern is. So 437 times 10. We can figure that one out. We know that 437 times 1 is 437. There is 1 0 in 10, so put a 0 on the end. And then we think about it. What happened? We moved the decimal 1 place to the right because there was 1 0 in our power of 10. All right, go finish filling out these 2 charts and answer these two questions here. It's an investigation. I know I give you the option every day to work with someone as long as you're on task. I highly encourage it on these investigations. It's really good to think about this with a friend.